Hi, welcome to my video on graphing the motion of a particle on a line number 2. The motion of a particle on a line number 2. Let me get this separated here. Okay. S of t equals 1/3 t cubed minus 3 over 2t squared plus 2t. And this is the position, and m is the distance, and t is the time greater than or equal to 0, represents the position of an article moving along a straight line. Graph the motion of the particle. Okay, so we graph the motion at time 0. So the s of 0 is the position, is 1/3 of 0 cubed minus 2/3 of 0 squared plus 2 times 0. So when t is 0, we fill 0 into this expression, and we get 0, 0, and a 0. So that means that when the time is 0, and let's say the time is 0 right here, when the time is 0, the position of the particle is 0. So this is time, and this is meters. So it's right at 0 that this particle is starting off at. Now, let's look at the derivative, s prime t, which is the velocity, and the derivative of 1/3 t cubed is 1/3 times 3 is 1, so it's t squared. 3 over 2 times 2 is negative 3t. Derivative of 2t is plus 2. And if we make this derivative equal to 0, that means we get t squared minus 3t plus 2 equals 0. This is a quadratic, so let's see if we can factor it. T squared is t and t. Factors of 2 are 2 and 1. Products is positive, sum is negative, so there's got to be 2 negatives. So that means t minus 2 is equal to 0. T minus 1 is equal to 0, so t is 2 or t is 1. So that means at 0 and 1, the velocity is 0. The particle is stopped at 1 second and 2 seconds. So if we put 1 second and put time, if we put 1 second here and 2 seconds here, that means we have an interval in between. So let's look at, we could look at when the prime t prime is greater than 0, that means it's going to the right. And we could look at t prime of t is less than 0, that means it's going to the left. So that means it's going to the right when there's a plus, and it's going to the left when there's a minus. So if we take these 1 and 2 and put in here, so we put a 3 in, and we put between 1 and 2 is 1.5, and at 0, this time is 0. If we got a 0 here, we know it's it's 0. So what happens? Take a half in between here. So at 3, so we take a 3 and plug it in this right here. A 3 here is a plus. A 3 here is a plus. So that means that the derivative is positive. So it's moving to the right. What about between 2 and 1? 1.5. Put a 1.5 here is negative. Put a 1.5 here is positive. So that means between 1 and 2 it's negative. So it's moving to the left. And we put a half in here. A half is negative. Put a half here, we got a negative. Negative and negative is positive. So between 0 and 1 second, it's moving to the right. Between 1 and 2 seconds, it's moving to the left. between 2 greater is moving to the right. So, as a result, we got 1 and 2 seconds. So let's do, when the time is 1, let's do the S of 1. At 1 second, where is the particle? So it's 1/3 times 1 cubed minus 2/3 of 1 squared plus 2 times 1. So I sub 1 in here, here, and here. Work this out. 1 cubed is 1, so that's a 1/3. 1 squared is a 1, so it's negative 3 over 2. 2 times 1 is 2. So let's put the common denominator is 6 for all of these. 3 into 6 goes 2. 2 times 1 is 2. 2 into 6 goes 3. 3 times 3 makes it a negative 9. And there's a 1 there. So 1 into 6 goes 6. 2 times 6 is 12. So that gives us negative 9, 3. So that's a 5 over 6. So that means at 1 second, it's 5/6 away from 0. So at 1 second, it's 5/6. So if we say this is 1, so 5/6 would be, let's make 5/6 roughly right here. And at 1 second, it's 5/6. So right there. It starts off right here. And let's look at the S of 2. So we got 1/3 2 cubed, 3 over 2 with 2 squared, plus 2 times 2 again. I sub 2 in here, here, and here. Work that out. That's 2 cubed is 8. 1/3 of 8 is 8 over 3. And I have 2 squared is 4. 2 into 4 is 2. So 3 times 2 is 6. 2 times 2 is 4. So that's 8 over 3 minus 2. So that's 8 over 3 minus 3 is a common denominator. So I get a 6. 6 over 3 is the same as 2. So that's 2/3. So that means at 2 seconds, the particle is at 2/3. So this is, remember, this is time and this is S. This is time and this is S. So at 2 seconds is at 2/3. And 2/3 is the same as 4 over 6. So 4 over 6 is a 5 over 6. So let's put 4 over 6 right here. So at 2 seconds, it's 4 over 6. So how do we graph this particle? So the particle is moving to the right. It's moving to the right. So between 0 and 1 second, between 0 and 1 second is moving to the right. So 0 and 1 second is moving from here over to 1 second is at 5/6, so it's moving along this way, right here. And then it stops and it's moving to the left. It's moving to the left from 1 to 2 seconds, and 2 seconds is at 4/6. So it's from 1 to 2 seconds, it's going back the other way, back to 4/6, right to there. And then at more than 2 seconds, it's going to the right. So at 4/6, more than 2 seconds, it's going to the right. So it turns, stops, and turns, and goes back this way. So the first derivative gives you the left and right. So we got the derivatives done, and getting the position of the articles. Find at time intervals. So at 0 time, at 1 second and 2 seconds, we got the positions, and then the derivative tells us by working this out when it's going left and when it's going right in relation to the 2 seconds and 1 second. So hopefully you understand, see how it all works out. Again, this st is the position on the curve, and the derivative is the time interval where it's changing to left and right. And if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. There's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.